Hey everyone, let's start with question number 3. Analog electronics asked in GATE examination 2025 electronics and communication branch. The question says which of the following statement is or true with respect to the ideal op-amp. So it is an MSQ question, so be careful and read all the options. So let's write a complete table on the practical and ideal values, because you also have to know about the practical values. It will be good for your interview questions, and you should be aware of the typical practical values of op-amp and other devices as well. If some questions asked in BJT MOSFET, so I'll always write the typical practical values of the above. Now what are the characteristics parameter? We will write here. First is input impedance. Yes, we also have to write about ideal versus practical. So the input impedance is ideally is infinite, and practically you will find it as 2 mega ohm. It is written in the specification sheet. And the next is output impedance. Which is 0, and practically it is 75 ohm. The third is your open loop differential gain, which is infinite ideally, and practically it is 106 dB, which is very large. If you convert into a linear scale, it comes out to be 2 lakhs almost. Fourth is your open loop common mode gain, which should be ideally 0, and it is by calculating the practical values, it comes out to be 16.02 dB. If you convert this into a linear scale, it comes out to be 6.32 approximately. Fifth is your bandwidth, which should be ideally infinite, and it is practically 90 dB. Sixth is your input offset voltage, I will write it down. Set voltage, so it should be ideally 0, and practical value is 1 millivolt. Now we have to extend this table, so let's see I can do this or not. No, I have to draw the another block. Okay, no problem. Let's write 7th, which is slew rate, which should be ideally infinite, and practically it should be 0.5. We must aware of unit of slew rate, which is volt per microsecond. So many times it is asked in interview question, what is the unit, although it is very basic, but each and every time most of the student used to say microvolt per second or megavolt per second. Although it is correct, it is not every unit is correct, but in the specification sheet slew rate is always written in volt per microsecond. So now your I think I have covered all the no, one is remaining, which is common mode rejection ratio, CMRR, which should be ideally infinite, and it should comes out to be 90 dB. Oh, sorry for one mistake I have done. If you can see the bandwidth, it should be unit in hertz, and it is comes out to be practically 1 megahertz. By mistake I have written CMRR here. So bandwidth ideally it should be infinite, practical is 1 megahertz. So I think it is clear. So these are all the parameters which have their ideal and practical values. So you can see the values which are much higher, ideally they should be infinite, and the values which are much lower, they should be ideally 0 or tends to 0. So based on this table, the option, let's check the option. It has infinite input impedance, less, option is correct. It has infinite output impedance, no, it is not correct. It has 0 output impedance ideally. So question says ideal op amp. So third option is it has an infinite open loop differential gain. Yes, it has ideally infinite open loop differential gain. Option C is correct. And the option D says it has infinite open loop common mode gain. So common mode gain should be ideally 0. CMRR says differential mode gain upon में common mode gain. So differential mode gain should be infinite and ideally, and common mode gain should be as low as possible, and ideally it should be 0. It is due to the noise, you should know this. So as low the noise can be figured out. So that's why it is 0. And differential gain, it depends upon the circuit, so it should be as high as possible. Write this as a circuit. So circuit gain, and this is a noise gain. I think everything is clear. So option A and C is correct. Please remember this table, it is very important. Thank you.